Tuscaloosa Center for Technology campus on Martin Luther King Boulevard, Tuscaloosa, Alabama. We're Team 3, consisting of Joey McKelvey, Ryan Alnafasa, Jeremy McMillan, and Jonathan Powers.
Project overview: demolition of the old West Lawn Middle School building on Martin Luther King Jr. Boulevard. Construction of $24 million Tuscaloosa Center for Technology campus. Primary contractor is Harrison Construction. Demolition is done and preliminary grade work is nearly complete. Underground retention pond has been built. Stormwater and utility piping is currently in progress, which brings us to observed cycle. Subcontractor is Price Construction, utility and drainage system construction. Installation of 36 by 22 inch arch pipe, 8 feet joints, and total length observed 200 feet of pipe, straight line. Total time of observation is 3 hours 52 minutes. No backfill will be left exposed until January 15th.
Equipment used for this project included a Hitachi 270 LC crawler backhoe with 1.38 cubic yard capacity, John Deere 624H front end loader with pallet fork attachment, and 3 pipe fitters used as laborers. The following is a validated model of the entire project. The following 2 slides detail cycles within the model.
Here's the top portion of our model. We separated it to make it easier to read. As you can see here, we start with a pipe stockpile and a loader, and that's the John Deere. The John Deere picks up the pipe and hauls it as far as it can, has to wait for traffic, and then once done with that, it continues the haul and drops the pipe off at the track hoe at the new stockpile. Then it continues to return, waits for traffic, returns a little bit more, and this idle time right here is not technically idle time. It was actually working on different portions of the project, but because those portions had no bearing on our part of the project, we just wanted to include those times for statistical analysis. That brings us to the next part of the model, which is the track hoe pipe fitters portion. While the pipe is being brought, a track hoe digs the excavation trench, and then once that's done, 2 laborers will check the grade, and then after that is done, a laborer attaches the pipe to the track hoe. Once that's finished, the pipe is lifted and swung to the hole, and once it's over the hole, a laborer soaps the connection, which is really just a cement type grout that eases the connection, and another laborer holds it in place while it's hanging off the track hoe. The pipe is lowered into the hole, position installed. Then here is the Titan pipe portion, where the steel cable is taut towards the back connection, and this this makes a better connection for the pipe. Once that's done, laborers will dig a little bit and add a little dirt underneath the pipe to correct the grade, and then after that, the track hoe presses and positions the pipe by tamping lightly on the top to fix the grade. Once that's done, the pipe is installed and it goes to the pipe installed queue. Then the track hoe is detached, reverses, and the portion starts over. The model was run until the pipe installed queue contained 25 units of pipe. The model was replicated 5 times for an average time. Actual project time was 3 hours 52 minutes, like we said earlier, and the Easy Strobe average time was 3 hours and 44 minutes. It's not that far off. We felt like we did a good job.
Sensitivity analysis. Model 2 changes included 2 total loaders, increased track hoe bucket size from 1.38 cubic yards to 1.6, widened haul to eliminate traffic wait time. Model 3 changes included only 1 loader, increased track hoe bucket size from 1.38 cubic yards to 1.60 cubic yards, widened haul to eliminate traffic wait time.
Once we ran those analyses, we came up with these sensitivity and cost analysis results. As you can see here, we have the actual model and models 1, 2, 3 from Easy Strobe. The shortest time was given to model 2, which was the 2 loaders. It also had the largest pipe per hour output, and also the highest cost, which makes sense. It has an extra piece of equipment. It has the lowest cost per pipe because of the productivity, and then second was Model 3, then Model 1, and then the actual. We think the actual is highest, obviously because of unaccounted for labor time and the small difference in our validation. In terms of cost per pipe, Model 2 provided the lowest cost, but it does not take into account the method of ownership, buy, lease, or rent that may increase the price, because it is simpler and more cost-effective in the long run to simply attach a new bucket to the Hitachi's Axis 270 LC than it would be to attain and implement a new loader. We recommend Model 3, which included one John Deere 624H loader, pallet fork attachment, one Hitachi's Axis 270 LC, 1.6 cubic yard heavy-duty platelet bucket, a widened haul lane, and 3 pipe fitters. And that concludes our presentation.